Hey, welcome back to Well, That's Interesting, the prepare yourself, I'll be saying the word tit a lot edition. Today is episode 192. This bird actually makes a polite gesture, and this worm has an enormous pair of eyes. I threw you a curveball there. No, my friends, the tit we'll be covering today is the Japanese tit, a very tiny bird about whom researchers made a big discovery. I ask, when was the last time you waved goodbye? Or gave a thumbs up, graced someone with your middle finger, or pointed to something gorgeous, outrageous, or at a necessity with your index finger? When was the last time you shared a TikTok, an article, or a video? Well, my many-limbed business goose, we do shit like this so often, and it's so ingrained in our behavior, you'd be forgiven if you don't really think about it. These types of gestures, and oh so many more depending on cultural context, are an essential part of how we communicate. And for a very long time, it was believed only humans did such things. Well, that has changed. Upon closer inspection of certain animal friends like elephants and great apes, such as chimpanzees and bonobos, boy howdy, wouldn't you know it, they move their bodies to communicate non-verbally too. And even more astonishing, and dare I say adorable, if you scroll on back to episode 141, pigs break up fights between fellow pigs, and chimps show each other leaves like we share social media posts, you will hear the story of how researchers, discovered that chimps show each other leaves like we share social media posts. A team from the universities of York, Warwick, and Zurich were kicking around a national park in Uganda when they recorded 11 seconds of video showing one adult chimp named Fiona nibbling on a leaf, pausing, looking at it, and then, with one arm extended, she put it in front of the face of an older female chimp named Sutherland. Now, Sutherland is Fiona's mom, and like any tired mother, she looked at the leaf and then looked away like, yeah, good job, I'm busy. This brief moment between mother and daughter made shockwaves. As explained by eurekaalert.org, quote, humans begin to use referential gestures to show or point out objects or events of interest to others in the first year of life. But until now, primates have never been seen engaging in this behavior. All previously documented referential gestures in primates were given to request something, not just to share attention, end quote. So, sharing attention, that's pretty incredible. But if you're thinking, well, they're close relatives, right? So it makes sense. I mean, it's not like we're going to see referential gestures in fish or birds, right? Well, hold on to your luscious cheeks. Ravens and fish have also been documented using simple gestures to point out objects or to show something of interest. Again, this is called referential gestures, but it's also called dictic gesturing. Now, let's try and concentrate because here is where things get even more interesting. Symbolic gestures, like waving goodbye or showing an open hand to signal after you, requires more complex cognitive abilities. My friends, up until like 5 minutes ago, there have been no conclusive evidence that symbolic gesturing exists in other species than humans. Well, that's all going to change in the first half of the show. My friends, the Japanese tit doesn't just dick. Sorry. These birds are the first non-human species officially known to use symbolic gesturing. And I can't wait to tell you what that romantic, courteous gesture is. Then after the break, your eyes won't believe these eyes. My friends, we're going to talk about a worm with such advanced eyeballs, they measure up to those of mammals and octopuses. Now, if you're thinking worms typically don't have that kind of ability, you're absolutely right. And this is not the only fun fact about these animals. Its appearance will stop you in your tracks, as will its superhero abilities. We will get to it. Until then, I'm Jill Chacha, and if this is your first time listening, welcome to the flock, my squinty business goose. To begin, my friends, I'm gonna need to describe a tit. Well, many tits, actually. The abundant Japanese tit, which we will learn shortly is a remarkable bird and an animal unlike any other when it comes to communication. If you head on over to our social media stuffs and tap on today's post, you will see a picture of one of these cuties. And I'll be honest, when I see this tit, I just want to pop it in my mouth. I don't know about you. I just want to eat it. And we spoke about this kind of response to adorable things back in February during episode 175, Cute Aggression, or Why You Want to Strangle Adorable Things, and eyelid twitching. What's up with that? If you haven't had a listen, god damn, it was a good time. So please be sure to take a moment. And if you're just still too fucking busy and you don't have our social medias up to take a peek at this bird, you are too busy. I'll just describe them to you in the meantime. Although ebird.org labels them as, quote, large and pugnacious, they're only about 6 inches long and weigh under an ounce. And if you're familiar with the common house sparrow, they kind of have that profile and build, but they aren't beige or brown at all. Their head is stark black, and under each eye is a flashy white smear. Those black feathers travel down their white bellies as a stripe, meeting a pair of gray wings with a hint of green near the shoulder. So, ooh la fucking la. As their name suggests, they are found all over Japan, but their territories also expand west into South Korea, eastern China, and down to Vietnam. With those stubby black beaks, they eat fruits, seeds, insects, worms, and spiders, basically your average omnivorous bird diet. But their social life, well, this is what's been making the news since the bullshit year of 2016. During the non-breeding season, from autumn to winter, these tits form flocks of 10 to even several dozen, composed of birds that include other species of the tit family that live nearby. So it's just a bunch of tits, everybody, just hanging out. And even more good news, their breeding season is a party nearly all year long, starting from late January until September. They form monogamous pairs, where the female builds bowl-shaped nests, and both parents take care of about 7 to 10 eggs, which hatch a mere 2 weeks later. The chicks then go on to college just 19 days later, so please put a pin in his family time. We will get back to it. First, we need to talk about Associate Professor Toshitaka Suzuki, an animal communication researcher at the University of Tokyo. Now, over the years of doing this show, you and I have met many a researcher with an obsession. But Professor T beats out a lot of them. He's been observing these tits for the past 17 years, and stop smirking, I can see you. He knows them so well. Not only could he identify them by their calls, he could even identify when a call changed slightly by using a combination of other calls. This is what made shockwaves in the ornithology world 8 years ago, when he published a study proving, quote, they not only use specific calls to convey particular meanings, but they also combine different calls to create new phrases using syntactic rules, end quote, he told EurekaAlert.org. My glorious business goose, Professor T provided the first firm evidence for compositional syntax in a non-human animal. What the fuck does that mean? I got you. Long story short, if you speak a language or several languages, they all have something in common. Compositional syntax, which is a fancy way of saying the ability to produce a new meaning by combining the same words in a different order. For example, open the door versus the open door. Now, if you stop and think about it, even with that simple example, compositional syntax is extremely complex. And my friends, humans and this little bird brain are the only two species known who can do this. Needless to say, when you study an animal with this kind of mind, you stick with it. You may never know what they have up their feathered sleeve. Fast forward to March of this year, when Professor T and his colleagues published a study that not only lived up to the banger in 2016, but surpassed it. For you see, Professor T and his co-researcher Norimasa Suguta, also from the University of Tokyo, they got to thinking, if these tits have the mental capacity to use such vocalizations, maybe we should concentrate on their physical gestures too. What could they possibly be saying to one another non-verbally? Well, With such a question, an experiment was to be had. So, in a little prefecture named Nagano, the team tied a few breeding boxes or birdhouses to local trees during the breeding season. And you really need to see just how fucking cute these little houses are. So please, just please stop looking at your children or a loved one, just ignore them and pick up your phone. Tap on today's post and swipe past the one photo of a tit, and behold, one photo of a birdhouse. When I saw this, I screamed with delight. So, are you looking? Yeah, I love the little awning above the entrance, like protecting the entrance from rain. There's like a little awning, and I love the tiny entrance even more. It's so tiny, only one tit can stick out at a time. And you can see it there poking its head out. This is going to keep going. So, now the size of this entrance is not a mistake. These birds find holes and structures like this all the time when opting out of building a nest. So, with a few of these vacant houses up, the team waited. And thankfully, they didn't have to wait long. 8 breeding pairs took up residency in these little studios, and you know what? I don't blame them. They're adorable. In 2 short weeks, each had a family, and the parents went to work. And by that, I mean find food for all the new little beaks. When they returned, things got interesting. After analyzing 320 nest visitations, what did they see? Drumroll, please. Thank you in the back. Quote, the researchers noticed that when carrying food back to the nest, the birds would often find a perch nearby first, and then one would flutter their wings towards the other. The researchers saw that the wing fluttering display prompted the mate who was being fluttered at to enter the nest box first, while the one who fluttered entered second, determining the order of the nest entry and mirroring the after you gesture observed in human communication. End quote. From eurekalert.org. Yes, you fucking heard me. Yeah. Since only one tit could fit through the entrance at a time, one bird would quickly flutter its wings to signal, after you, sweetie. And I have a photo of this over at our social media stuffs. It's adorable. But if you want more, and I understand, and you want to see a video, you totally, surely can. Simply search Japanese tit bird after you gesture. And lots of links will come up. Just be sure to use all those words or you're going to get a different video. Now, at this point, I know what you may be thinking. My practical business goose, you may be thinking, okay, this is adorable. But how do we really know this is a symbolic gesture? And I need the tit tea. Who let who into the nest first more often? Well, let's get to the gossip first. According to the study, simply called the after you gesture in a bird, the gesture was performed more often by the female birds, after which the male usually entered the nest box. And get this, the gesture was performed more often by female birds regardless of who had arrived first. The male would wait for the female to arrive, and then she decided who went in. If the female didn't flutter her wings, it was she who usually entered the nest before the male. It's also fucking polite and adorable. It's gross. Now, does this fluttering qualify as a symbolic gesture? Well, the researchers believe it truly does. 1, it only occurred in the presence of a mate, and it stopped after the mate entered the nest. 2, the fluttering encouraged the mate to enter the nest box without any physical contact. And 3, y'all, the wing fluttering was aimed at the mate, not the nest, meaning it wasn't being used as a dictic gesture to indicate something of interest. So, pretty wonderful, right? But naturally, we must ask, why? Why would a bird need something like this? And how does something like this even come about? Well, Norimasa Suguta has a pretty good theory. As I told Eureka, quote, there is a hypothesis walking on 2 legs allowed humans to maintain an upright posture, freeing their hands for greater mobility, which in turn contributed to the evolution of gestures. Similarly, when birds perch on branches, their wings become free, which we think may facilitate the development of gestural communication. End quote. well, my human flock, birds, which have been evolving for millions of years, and in this case, the Japanese tit has learned to use their free limbs to communicate. So, what else could they be saying? And should we be concerned for our well-being and safety? You know what? Fuck it. Let them have it. I'm tired. After the break, we're moving on from fluttering wings to gigantic eyeballs that are completely out of proportion to the body they're connected to. Well, there is a method behind nature's drunken madness sometimes. You need to see and hear about this next creature. Stay tuned.
Hey there, I'm Dylan Lewis, one of the hosts of Motley Fool Money. Each weekday on Motley Fool Money, we talk through the business news you need to know and the stories moving stocks on Wall Street. On weekends, we dive into the industries shaping tomorrow and host the experts, authors, and executives that understand them. Tune in for insights, a long-term perspective on investing, and of course, stock ideas. Plenty of them. To quote a listener, it pays to listen. Check us out and subscribe wherever you listen to podcasts.
If you enjoy bizarre true stories, then the Useless Information Podcast is the podcast for you. For example, did you know that author Robert Louis Stevenson gave his birthday away? Or that there was a football team that played for 6 years before someone realized that the school never ever existed? Or that a dog in upstate New York was once placed on trial for murder? Well, to hear these and hundreds of additional fascinating true stories from the flip side history, be sure to check out the Useless Information Podcast. That's the Useless Information Podcast, podcasting worldwide since 2008 and available on Apple Podcasts, Spotify, or wherever you're listening right now. Be sure to check it out.
And we're back. We are so back. And my friends, I'm going to ask you to pack some sunscreen and a Speedo because I've just booked us first-class tickets to Rome. You're welcome. Now, once we land, however, we're going to need to make a connecting flight. But don't worry, the island we're heading to is paradise incarnate. So please, everyone, imagine Italy. Thank you. Now point to the middle of the boot on the left-hand side. Okay, there is Rome. And please move your finger south until you reach the point where the leg meets the foot. Okay, good. There is Naples. Now, last time, move your finger left into the Gulf of Naples and then up just a smidge. Just a smidge. Perfect. My friends, we've just landed on the island of Ponza, whose waters are so pristine and whose beaches are so sun-drenched, it is the getaway for Romans and Neapolitans. Only this island will do. However, someone else is here. It's not just you, me, and half-naked Romans. There's also neuro and marine biologist Anders Garm from the University of Copenhagen, Michael Bach from Lund University, and some very special marine worms. Did I ruin it for you with the marine worms? Well, I promise this will be worth it, I promise. Please, everyone, head on over to our social media stuffs once again and swipe past some tits. Okay, behold, do you see it? This is the Vanidus, and I'll give you a second. I know, it's a bit much. First, let's talk about the body, okay? Now, you'll be forgiven if you saw this creature and it reminds you of a silvery, sparkly centipede, but nay, this is a worm. Specifically a species of marine bristleworm, which means, yes, these babies live in the water we're swimming in right now, and yes, each body segment has a pair of fleshy protrusions called parapodia that bear many bristles. And even more good news, this is merely one of 10,000 species in this class who grow from 1 to 6 inches in length, although the biggest of them can grow to 24 inches, which I believe is unnecessary. Okay, today we are only focusing on Vanidus, and boy howdy, for a very good reason. Well, actually for 2 good reasons. Take a gander at the 2 orange bulbs at the very top of the worm, at the very end there. Those are eyeballs, and if they look too goddamn big for its body, you are exactly right. let's get into it. My friends, several months before we arrived at Panza, Michael Bach showed his colleague Anders Garm a video of this worm, and the two became inspired. Quote, "Together, we set out to unravel the mystery of why a nearly invisible, transparent worm that feeds in the dead of night has evolved to acquire enormous eyes. As such, the first aim was to answer whether large eyes endow the worm with good vision," end quote, said the Bach to science.ku.dk. Well, my average-eyed business goose, before we get into the tests and the results and the theories as to why, for the love of God, this is a thing, we need to put these peeper proportions into context. If you and I had the same eyeball-to-body ratio as Vanitas, we'd be lugging around an extra 100 kilos or 220 pounds in our heads. That's a bit much. So what the fuck do these monstrous eyes actually do? Well, hold onto your seafaring cheeks. The team went to Poketown on this worm with electrophysiological tests to determine what kind of receptors were in those eyes. Knowing what receptors they have determines what wavelengths of light that they could see. Now put a pin in this. They also performed an optical analysis to get an idea of the kind of resolution they could see in too. And after all the clickety-clack calculations were made, drumroll please, thank you again, the team couldn't believe what they were seeing. This worm has what can be described as, quote, outstanding vision, end quote. Now, you're probably thinking, well, no shit. But how common is this for a worm? Great question. Buckle up. Quote, "It's really interesting because an ability like this is typically reserved for us vertebrates, along with arthropods like insects and spiders, and cephalopods like octopus and squid. This is the first time that such an advanced and detailed view has been demonstrated beyond these groups. Its eyesight is on par with that of mice or rats, despite being a relatively simple organism with a minuscule brain," end quote, said the Garm to science.ku.dk. So, fucking round of applause. This itty-bitty, transparent worm can roll with the likes of rats and octopuses in the dead of night. Why? Well, to hunt and find food, of course. These peepers can surely see small objects and track their movements with no problem. But the Garm went on to tell science.ku.dk that not only does feeding happen at night, but mating and all other social activities. So they're really Italian after all. My friends, get this. Their receptors pick up UV light only seen by their own species. I'll say that again. Their eyes pick up light only seen by them. Which, I know, which means they probably use a secret UV bioluminescent language to communicate. This is a brilliant way to avoid predators or gain the attention of anything else around you. Perhaps that is the trade-off for such heavy, ridiculous eyes. Of course, when you find such brilliance in nature, it usually inspires humans, and that's exactly what's happening here. As science.ku.dk explains, as a result of the discovery, Anders Garm and his research colleagues have also started working with robotics researchers from the Meirik McKinney-Mahler Institute at the University of Southern Denmark, who find technological inspiration in biology. Together, they share a common goal of investigating whether it is possible to understand the mechanism behind these eyes well enough as to translate it into technology. Together with the robotics researchers, they are working to understand how animals with brains as simple as these can process all of the information that these large eyes are able to collect. This suggests that there are super smart ways to process information in their nervous system. And if the team can detect these mechanisms mathematically, they could be integrated into computer chips and used to control robots, end quote. Well, yeah, I guess. Who doesn't want supercomputing AI with, quote, outstanding night vision. I only see good things here. So thank you for listening, rating, subscribing, telling your friends about how fucking polite these tits are. Just text them right now. Just tell them about these tits with like really no other context. And tell them about this worm that sees light on, I'm stuttering because it's so phenomenal that they see a type of light that only they can see. I'm sweating. Okay, and a military-grade thanks to the folks over at Airwave Media, the podcast network to which WTI belongs. If you love this show, and you do, you'll love the other podcasts in this family. And please, stay interesting.